Hello, today's lecture will be on design of riveted joints for axially loaded members. In the last lecture, if we see that we have discussed details about the riveted joints, particularly on various modes of failure of rivet joints, like we have discussed the tearing of plate between rivet holes, shearing of rivet, then bearing of rivet or plate, then edge cracking. So, how the rivets are going to fail, those details has been discussed in last class, and also we have shown what is the efficiency of a rivet joints, that also how to calculate we have discussed, and the strength of the rivet joints for a given dimension and for a given configuration of the rivet, the strength of the joints can be calculated, and those things details have been shown in the last class. So, today we will be focusing on basically on the design part, means for designing any joint with rivet, how to take care we will discuss here. Now, here we will see the criteria to remember for designing riveted joints with axially loaded members. Now, what are the criteria we supposed to, means we need to remember before going to design a rivet joints. First thing is how to select the diameter of a rivet. This can be selected through some approximate formula which has been given, that d is equal to 6.04 root over t or 6 root over t. From this formula generally we used to calculate the rivet diameter. Some approximate diameter we first like to choose from this formula, where t is the thickness of the thinner plate. If we have multiple plates, then the thinnest plate thickness will be taken consideration for designing the rivet joints, for designing the rivet diameter. Now, the length of joint, we have to remember that length of joint should be as small as possible to save material on cover plates and gusset plates. So, for designing the joint, first we have to know, means first we have to keep in mind that length of the joint should be as less as possible to save the materials. How? That means, suppose we have a say bar joint, say we have a plate here and we have a say rivet here, two rivets have been given, so this is one plate, and the plate is this one, has been covered by this extra gusset plate. Now, you see this is called basically pitch and this is the edge. So, this pitch and edge should be as less as possible, so that the length of the plate extra cover, whatever we are introducing for joining the two plate, the plate is one plate is this one, say let us see, this is one plate and another plate is this one. So, now to join these two plate, we need to introduce two cover. So, this cover of the plate should be as less as possible to save the material. So, while designing the joint, we should take care these aspects. Next is the number of rivets should be increased gradually towards the joint for uniform stress distribution in rivets. What does it mean? So, suppose we have a two plate, so let us see this point. So, some axial forces are acting on this plate, one plate is this one, another is this one, and has been connected through some plates. So, ideal configuration of the rivet joint should be like this. That means the number of the rivets should be increased gradually towards the joint for uniform stress distribution in the rivet, and the central line of all the members meeting at a joint should coincide at one point only. This is very important. The central line of all the members meeting at a joint should coincide at one point only, otherwise the joint will twist out of position. So, axial force only will not act in that case. So, some torsion will come into picture, that is why we have to take care properly. Another points we have to remember is the arrangement should satisfy the pitch, gauge and edge distance requirement. The code has given some provisions of gauge distance, edge distance and pitch distance. So, those has to be satisfied as per the codal provisions, means that minimum pitch distance, the 2.5 D, that has to be taken care, like all the codal provisions whatever is given which we have discussed earlier has to be maintained. Like suppose we have the rivet joints here. So, this is called, we know that edge distance and this is called pitch distance. So, pitch and edge distance should be, that minimum distance should be taken care, this is called gauge distance. So, this gauge distance also has to be as per the codal provision. So, this point has to be remembered. Another parameter is the strength of joint reduces due to the rivet holes. We know the efficiency we have calculated earlier, that strength of the joint reduces because of the reduction of rivet holes. The reduction in area due to rivet holes can be minimized by arranging in a zigzag form. Now what is the reduction that has been calculated in earlier cases we have shown. So, that can be minimized through the introduction of zigzag riveting. That means, suppose if we have a two plate, suppose this is one plate, another plate is joined through say some gusset. Now, in place of chain riveting, it would be better if we can make riveting like this. That means, here the weakest section will be either through this or through this. That means, reduction of area in this say section 1 will be less compared to section 2. That is why the section 2 will be weaker, and in section 1 the reduction will be 2 hole, and in case of section 2 reduction will be due to 3 hole, and another chances of failure will be say 1, say if I make say this is 3, say 4, 5, say 1, 4, 3, 5, 1. So, in this way another chances of failure. So, here also we will see, because of the zigzag riveting the additional strength will come because of this. So, reduction, if reduction is 3 also, but some additional forces will means additional strength will be added from that formula we know. So, this also we have to keep in mind while designing the rivet. So, with these parameters in our mind we can start our design. So, those design, basically design will be done through the applied force. What are the applied force, what is the plate thickness, what is the bearing, shearing and other details, all those things we have to know, and then accordingly we can design it. So, those things will be clear through one example. Now, I will work out some example through which we will be understanding how to design a rivet joint. Say in this case 2 plates are to be lapped having thickness of 12 mm and 16 mm. That means 2 plates we will be connecting through lap joint, and that will be has to be designed by the use of rivet. Using hand driven shop rivets, design the joint for an applied tensile load of 275 kN. So, what are the things has been told, that one plate, say rivet joint is given, So, this is one plate and another plate is this one, are lapped with giving some lap length. Now, this rivets pitch, rivet diameter and other things we have to calculate from this. So, these are basically hand driven shop rivets and 275 kilonewton forces are applied, axial force. Now, thickness of the plate is, this is 12 millimeter and this is 16 millimeter. Now, we have to calculate the details of the rivet joint. That means, we have to calculate means basically we have to find out what is the pitch distance, what will be the rivet diameter and how many rivets has to be provided, all this we have to find out. So, first let us provide some rivet diameter. Say for this case we are going to provide say 22 hand driven shop rivet diameter. Either we can provide arbitrarily like this or we also can provide from the formula the 6.04 square root t, from which the d can be calculated. However, here we are considering say 22 mm. Later I will show in other example that I have considered through this also. Now, the gross diameter will become 22 plus 1.5 mm. So, this will become 23.5 mm, the gross diameter of the rivet. Now, as per table 8.1 of IS 800/1984, we will see that shearing stress is coming tau Vf as 80 MPa and bearing strength will be 250 MPa. So, these values are can be find out from IS 800/1984. In table 8.1 these values are given. So, as per the type of rivet and other details we can find out the shearing stress and bearing strength of the rivet. Now, we can find out the strength of the rivet. So, to find out the strength of the rivet, first we will find out what is the shearing strength of rivet. So, first we will find out shearing strength. So, shearing strength will be tau Vf into pi by 4 d square, where tau Vf is the shear stress, allowable shear stress. So, this will be 80 into pi by 4 into, here d will be 23.5 m square. So, after calculating this we will get this is coming 34.7 kilonewton. Now, you have to multiply by 1000 to make it kilonewton, because this is given in Newton. Next, the bearing strength. So, two type of strength we will find out, one is shearing strength, another is bearing strength. So, bearing strength of the rivet will be bearing strength of the rivet, that can be calculated from the formula, that is sigma Pf into d into t. That means 250 into d means 23.5 into t means the thickness. Now, thickness will be basically the two type of thickness has been given. If we see that one is 12 mm, another is 16 mm. So, thickness we will consider the weaker one, that means the lesser one 12 mm, because 12 mm will carry less strength. So, failure will be first on the 12 mm plate. So, we are going to calculate on that basis. So, this will come 70.5 into 10 cube Newton, that means 70.5 kilonewton. So, rivet value can be find out from these two, lesser of these two. One is 34.7 kilonewton due to failure through shear, and due to failure of bearing this will be 70.5 kilonewton. So, the rivet value will become the lesser of these two 34.7 kilonewton. So, in this way we can find out the rivet value. That means, the shearing strength of the rivet we are going to get 34.7 kilonewton and bearing strength of the rivet we are going to 70.5 kilonewton. That means, the failure will first occur because of shearing strength. So, we will find out the rivet value as the lesser value of these two, that means 34.7 kilonewton. Next, number of rivets can be find out from here. Number of rivets required will be the total force acting by rivet value. That means, total force was 275 kilonewton, rivet value is 34.7 kilonewton, this is coming around 7.9, that means 8. So, we can provide say 8 numbers 22 hand rivets of rivet. So, for designing we need 8 number of 22 diameter of rivets. Now, we have to know what is the pitch, what pitch we will provide. Now, from the codal provision we know that minimum pitch will become 2.5 D, that means 2.5 into 22, that means 55 mm, and maximum pitch will be that also has been given in the code, which will be 32 into T, that means 32 into T is 12, so 384, and this will be 32 T or 300, whichever is less. That means, maximum pitch cannot be greater than 300 mm. So, out of these two we will provide 300 mm. So, maximum pitch is 300 mm. So, from these two criteria we can find out what should be the pitch. That means, minimum pitch we can provide 55 and maximum pitch we can provide 300. So, in between we can provide. Now, as per table 8.2 of IS 800/1984, the edge distance will become for this case 38 mm. Now, we have to configure this through pitch and edge. So, we have to go through some trial, say first trial. Let us take the gauge distance, say 50 mm. Then what will be the width? Width of the plate will become 38 into 2, this is the edge distance in two side, plus 50 into 3, because we have the number of rivets, total number of rivets are 8. So, 3 gaps will be there. So, this will become 226 millimeter. So, area of critical section will be 226 minus 4 into 23.5, because in each row we are providing 4 number of rivets. So, this is the reduction due to hole and this is the width into 12 mm thickness. So, this will become 132 into 12. So, 1584 millimeter square. Now, the allowable stress sigma AT is equal to, we know, 0.6 Fy, that means 0.6 into 250, which will become 150 MPa. So, allowable stress is this. So, the permissible load on critical section will be the total area into allowable stress, which will become 237.6 kilonewton, which is less than 275 kilonewton. That means, in first trial what we have done, that first we have assumed that gauge distance as 50 mm. Now, as per that gauge distance, we will get the width as 38 into 2 plus 50 into 3 is equal to 226 mm, because in each row we are providing 4 pitch, 4 rivet. So, in between distance this will be 50 So, 50 into 3 plus 38 into 2, this is the edge. So, in this way we can calculate the critical section area of the critical section in which rivet may fail, that is coming 1584 millimeter square. Now, the sigma at value is 150. So, permissible load on the critical section will become 237.6 kilonewton, which is less than 275 kilonewton. That means we have to go for redesigning. That means the plate is going to fail before the total load is going to act. So, we have to make it in such a way that at least 275 kilonewton load can be distributed. How? That means we have to increase the width. That means we have to increase either this pitch or the edge. In this way we can make it. So, let us go for the second trial. In second trial, let us take gauge distance G is equal to say 60 mm. So, width will become in this case 38 into 2 plus 60 into 3. So, this is coming 256 mm. Now, area of the critical section will become the width 256 minus 4 into 23.5, this is because of reduction of hole into 12, that is coming 1944 millimeter square. So, permissible load will become 1944 millimeter square into 150, that is coming 291.6 kilonewton, which is greater than the applied load 275 kilonewton. So, we can say this is okay. So, if we provide the gauge distance as 60 mm, then the width is becoming 256 mm. Thus, the area of critical section is coming 1944 mm square and the permissible load is becoming 291.6 kilonewton, which is greater than 275 kilonewton. So, this is okay. If we do not consider the G value, that also we can find out from the equation. How? That we can find out simply 38 into 2 plus G into 3 into 12 minus 4 into 23.5 into 12 is equal to 275. So, from this equation also we can find out the exact G through which the section can carry just 275 kilonewton. So, in this way also we can calculate. So, in conclusion what we can tell that we can provide 22 diameter of hand driven soft rivet with a pitch of 55 mm and a gauge of 60 mm center to center with an edge distance of say 40 mm as shown in the figure. So, if we see the figure now, the drawing will be like this, because the designer when designs, he has to make the drawing in such a way that the construction engineer can follow that drawing. So, drawing has to be complete in all sense, so that the execution time the engineer should not have any confusion. So, now there is 2 plate, 4 rivets in each row we are providing, and the pitch distance is 55 mm we have taken. This is the minimum, and this is we are taking 40, and this distances we are taking 40, 60, 60, 60, 60. In fact, this 60 can be reduced little bit, and so this total width is becoming, so this is 40, 60 into 3, 180 plus 40 into 2, 80, that means 260. So, total width of the plate will become 260 and the overlap length, the lap length will become 40 into 2, 80 plus 55, that means 135 mm. So, as I was telling in last slides that the lap length should be as less as possible to save the material. So, here we see that lap length should be at least 135 mm. Now, we will see some other example. This is another type of example, that is two 12 mm plates are to be joined using double cover butt joint. So, in earlier example we have shown the lap joint, here we will show the butt joint using 8 mm cover plate and power driven soft rivets. The applied load is 300 kilonewton. So, design the joint, also find the efficiency of the joint. So, here the joint is looking like this. Say one cover is given here, first let me draw the rivets first, then we will insert the plate. So, these are the rivet, this is a double cover joint. So, these are becoming this is one plate, the main plate is this one, this is 300 kilonewton force is acting on this main plate, and then another cover like this. Now, this is one extra cover we have put with having thickness of 8 mm. Here also another cover, it is a double cover. So, here also we are putting another cover, this is also given as 8 mm, and the main plate is of 12 mm. Main plate is this one, this is one plate, this is another plate. So, these are HDS, hand driven shaft. So, arrangement of rivets are like this. Now, I have to design it. Designing means again the pitch distance, edge distance and the gauge. So, all these things we have to find out. We have to find out. Okay. So, these are the things given. One is, let us provide some diameter of rivet, say 22 phi power driven shaft. So, the gross diameter of rivet will become 23.5 millimeter, and as per table 8.1 IS 800 1984, the shearing stress will become 100 MPa and bearing strength of rivet will become 300 MPa, because this is hand driven shaft rivet. So, because of this HDS rivet, this is given in the table 8.1 of IS 800 1984, from which we can find out. Now, we have to find out the strength due to shearing and strength due to bearing. So, shearing strength of rivet we can find out. Shearing strength of rivet, this will be, this is double shear. So, 2 into tau Vf into pi by 4 d square. So, this will become 100, tau Vf is 100, pi by 4 into d square means 23.5 square, because the whole diameter is becoming 23.5. So, after calculating this we will get 86.6 3.75 kilonewton. Similarly, the bearing strength on the rivet can be calculated from the formula sigma Pf into D into T. So, sigma Pf in this case is becoming 300 into D is 12 mm and T is 12 mm and D is 23.5. So, this is becoming 84.6 kilonewton. So, the rivet value can be find out from these two. So, we can find out rivet value R will become the lesser of these two value. So, it will become 84.6 kilonewton. So, in this way you can find out the rivet value. So, the shearing strength of the rivet which has been calculated from this formula 2 into tau Vf into pi by 4 by into d square, through which we can find out 86.75 kilonewton, and bearing strength of the rivet which has been find out from this formula sigma Pf into d into t, which is becoming 84.6 kilonewton, and from these two the lesser value has to be considered as a rivet value. So, rivet value we are finding out at 84.6 kilonewton. Now, let us see what will be the number of rivets is required. So, number of rivets required will be applied force was 300 and rivet value was 84.6. So, this is becoming 3.54. That means, we have to take 4 rivet. So, use 4 numbers of 22 5 PDS power driven shop rivet. So, this will be the answer. Now, again we have to calculate the minimum pitch, maximum pitch, and from those criteria we have to find out some suitable pitch. So, minimum pitch will become P minimum is equal to 2.5 D, that means 2.5 into 22 55 mm, and maximum pitch will become P max will become 32 into T, that means 32 into T means the lesser thickness, that is 12 mm. So, this is becoming 384, and in any case it should be less than or equal to 300 mm. So, out of these two we can find out the pitch. So, maximum pitch will become 300 and minimum pitch will become 55. So, from this we have to find a suitable pitch distance. So, pitch distance we can find out now as per the table 8.2 of IS 800, the edge distance will become 45. So, with this we can find out the gauge distance and other dimensions. So, let us use some gauge distance G. So, gauge is equal to G. Either we can do through trial as we have done in earlier case, or if we assume the gauge distance G and we can find out from the equilibrium equation. That means, if we use G, then this will become G plus 45 into 2 minus 2 into 23.5 into 12 into 150 will become, has to be equal to 300 into 10 cube. What is this? Because we have seen the total number of rivet is 4, that means 2 rivet in each line. To find out the plate width, we have to know what is the total width. So, if we assume this is a G, then G plus this is the edge distance 45 plus 45 minus the whole, 2 rivets are providing in one line. So, minus 2 into 23.5 into thickness, thickness is 12 and allowable stress is 150. So, these are the stress or these are the force which can be taken by the plate, and this is the force which has to be taken, that means applied force is 300 kilonewton. So, if we make equilibrium, from this we can find out G as 123.67 millimeter. So, we can adapt G is equal to say 125 mm. So, in this way we can find out G. So, as I was telling that in earlier example we have shown through trial method, here exactly we are finding out. So, both the way you can do, but I will suggest that we should go with this method, because exactly we will get, and according to that we can choose the gauge distance. So, the process what we have discussed, that how to find out the gauge distance and how to find out the total width of the plate. So, in this case we are adapting gauge distance as 125. The net area we can find out, net area A net will become 125 in plus 45 into 2 minus 2 into 23.5 into 12. This is the net area, which is becoming 2016 millimeter square. So, allowable load on joint will become this will become net area A net into sigma 80. That means net area is 2016 into sigma 80 value is 150, which is becoming 315.9 kilonewton, which is greater than 300 kilonewton. That means the edge distance whatever we have made is okay. So, what we are seeing, that net area because of hole of the rivet we are finding out as 2016, and the allowable load we are finding out as 315.9 kilonewton, which is more than 300 kilonewton. So, with this dimension, that means with considering gauge distance as 125 millimeter and edge distance as 45 millimeter, we can design the joint which will take care 315.9 kilonewton load. So, if we draw the figure, this will look like this. Say the plates are like this, and it is butt joint is here. So, here we are providing 4 rivet, 2 rivet in each row. This is the rivet line. So, this distance we have as 125 and this is 45 mm, this will become 45 mm. So, this will become total 215 mm. So, width of the plate will become 215 mm. Now, this will become 45 and this will become, say, pitch distance we have calculated earlier. As per that we can make that, say, 55 to save the material. So, this we can make as 55. That means this length will become 100 mm. 100 mm from the end of the plate we can make. So, in this way we can distribute the rivet. Now, we can find out the efficiency. So, this is the picture which I was drawing there. So, in this way you can make, that is 55 mm and this distance we made, that 125. So, whichever I have drawn, the same thing I have reproduced here. Now, if I want to show the efficiency of the joint. So, efficiency how do we find out? First we have to find out the strength of the rivet joint. What will be the strength? Strength of the rivet joint will be four rivets are there, 4 into rivet value 84.6, so 338.4 kilonewton. So, this is the strength of the rivet joint, and strength of the plate at the critical section we have to find out strength at the critical section. because the plate may fail also. So, the strength of the plate at that section has to be calculated. So, that will become 125 plus 45 into 2 minus 2 into 23.5 into 12 into 150, where this is the gauge distance, this is the edge distance. So, total width will be this minus reduction due to hole into plate thickness into allowable stress will become the strength, which is becoming 302.4 kilonewton. So, one is that 338.4 kilonewton due to rivet, and the plate strength will become 302.4. So, we can consider that the strength will be lesser of these two. So, strength of the joint will become say 302.4 kilonewton. Again, the strength of the solid plate will become, means if rivet is not there, if hole is not there, then the strength of the solid plate will become this one 125 plus 45 into 2 into 12 into 150. So, this will become 387 kilonewton. Now, we have to find out the efficiency. So, efficiency, how do we find out? Efficiency will be the strength of the riveted plate by the strength of the solid plate. So, efficiency we can make that strength of plate after riveting by strength of solid plate. That means, strength of plate after riveting will become 302.4, because this we have calculated. This is the minimum strength is coming out of these two, and strength of the solid plate is 387. So, by 387. So, this is becoming 0.7814%. That means, the efficiency of the joint will become 78 point, sorry, this will not become 78.14%. So, in this way we can find out the efficiency. Efficiency of the joint in this case, in this configuration is becoming 78.14%. Now, we will see through some other example. This is very important, because how to design a truss joint, truss member, that we will show here. Say, design the joint O of a lower chord of truss as shown in the figure below. Use hand driven rivets and assume the permissible tensile stress in angle as 150 Newton per millimeter square. Let me first draw the joint, then we will be able to understand what are the problem we have to make it. Say, this is the lower chord, this is having the center line here, and the force is this force is becoming 144 kilonewton in this side, and this side force is 250 kilonewton. This is the center point, say O, and from this another member has gone like this. So, this is 150 kilonewton, and another member vertically is acting, which is also having load of 106 kilonewton. This is 106 kilonewton. So, this point, let us, this member is OA, this member is say suppose OB, this member is OC and this member is OD, and this angle is say 45 degree, this angle is 45 degree, and the size of angle is, this is 2 ISA 90 90 10, and this member is consisting of one angle 70 by 70 by 10, and this is ISA 65 by 65 by 10. So, these are the details of the joint. Now, we have to design this joint. Say we have to provide some plate and we have to design accordingly. Say what will be the number of rivets for this joint, what will be the number of rivets for this joint, and what will be the number of rivets for this member, that we have to find out. So, now what we will do? First, we will assume some thickness of gusset plate. Let assume thickness of gusset plate. So, to start with, we have to assume some thickness. So, we have assumed as say 12 mm, because 10 mm thickness was for all the plate members. So, we are considering say 12 mm. Now, forces are given, say for member OA, this force is 250 kilonewton. So, these are given. Then FOB is also 106 kilonewton. Then FOC is having 150, all are axial forces, and FOD is given 144 kilonewton. Now, so here one thing we should observe, that minimum thickness of angle is 10 mm. This is one thing. So, accordingly we can find out the approximate diameter of rivet as 6.04 into minimum thickness of the all plates. So, this will become 6.04 into thickness as 10 mm. So, this is becoming 19.1 mm. Hence, we can provide 20 mm rivet. So, in this way also we can decide the diameter of a rivet. Otherwise, we can just approximately, we can assume some 20 or 22 or 18 or something, we can assume also. Now, the gross diameter will be 20 plus 1.5 mm. So, this will become 21.5 mm. Now, minimum pitch, let us find out. Minimum pitch which we need to provide is 2.5 D. So, 2.5 into 21.5. So, this will become 53.75 mm. So, let us provide say pitch as 60 mm, because minimum pitch we have to provide 53.75 mm and maximum is 32 T or 60 or 300, whichever is less. So, from this criteria let us provide pitch at 60 mm in this design. Now, for hand driven rivet, tau VF will be 80 Newton per millimeter square as per the codal provision, and sigma PF will become 250 Newton per millimeter square, and sigma AT will become 150 Newton per millimeter square. So, these are the values we have to consider from the IS code. Now, one by one member we can go. Say for member OB, that means the vertical one. that means this member. First let us design this member OB. So, what we will do? First we will find out the strength of rivet. Now, this is a, we can consider as a single shear. So, strength of rivet will become strength of rivet in single shear will become tau Vf into pi by 4 d square. So, tau Vf is 80 into pi by 4 and d is here 21.5. So, this will become 29 kilonewton. So, the rivet value due to single shear will become 29 kilonewton. Next, second will become strength of rivets in bearing. Strength of rivets in bearing on 10 mm thickness angle, because angle thickness is 10 mm. So, the bearing strength will become sigma Pf into d into T. So, that will be 250 into 21.5 into 10. So, this will become 53.75 kilonewton. So, this is another strength we are calculating due to bearing. Another is strength of angle per pitch, we have to find out. Strength of angle per pitch, strength of angle per pitch will become as per the formula sigma A2 into P minus D into T. So, sigma it is given 150 and pitch we have considered as 60, D will become 21.5 and T is the thickness of the plate means the angle. So, this is becoming 57.75 kilonewton. So, what we got, that we are getting rivet strength as 57.75 kilonewton per pitch, and due to bearing this is 53.75 kilonewton, and due to shearing this is 29 kilonewton. So, we have to take the lesser value of these three. So, the rivet value will become finally as 29 kilonewton. That means less minimum of case 1, case 2 and case 3. So, minimum of these 3 is coming as 29 kilonewton. Now, on this basis we can find out the number of rivets required, because we know the force. So, number of rivet required will be force in OB by rivet value. So, force in OB we have 106 kilonewton and rivet value we got 29. So, this is becoming 3.7. So, we can provide 4 rivet value, 4 rivets. So, we can say for member OB provide 4 number of 25 rivet. So, this will be the answer. Now, we will design later, means design means dimension of means configuration of rivets, what will be the pitch, what will be the edge and other things we will discuss later. So, for member OC let us see. So, in case of member OC, similarly we can find out the strength of rivet in single shear. Strength of rivet in single shear. So, this will become tau Vf into pi by 4 d square. So, this will be also similarly pi by 4 into tau Vf will become 80 and d is 21.5. So, this is same 29 kilonewton. Now, strength of rivets in bearing, that we have to find out now. Strength of rivets in bearing, this will be also same similar to earlier one, strength of rivets in bearing. This will become sigma Pf into d into T. Here sigma Pf will be 250 and diameter will be 21.5 and thickness of the angle is 10. So, this is also becoming 53.75 kN. And next slide. And the strength of angle per pitch will become, that means in case of 3, strength of angle per pitch will become sigma AT into P minus D into T. That means this will become 150 into 60 minus 21.5 into 10. So, this will also become 57.75 kilonewton. So, we can find out the rivet value are as 29 kilonewton. So, number of rivet required for this member OC, number of rivet will be required, force in OC by rivet value. That means this will be force in OC was 150 and rivet value was 29. So, this is becoming 5.2, that means we can provide 6. So, in this way we can find out the rivet value. So, next is for member AD. For member AD. So, for member AD, what will be the force FAD? That will be 250 in one direction and in other direction, opposite direction 144. So, the balance of these two, that means 250 minus 144, that means 106 kilonewton. So, remaining force in member AD is becoming 106 kilonewton. Now, strength we have to find out. Now, strength of rivet, here it will be double shear because double angle is provided. So, strength of rivet in double shear, that will become 2 into tau Vf into pi by 4 d square. So, this will become 2 into 80 into pi by 4 into 21.5 square. So, this is becoming 58 kilonewton. So, strength of rivet in this case is becoming 58 kilonewton due to double shear, and strength of rivet in bearing on 12 mm thick gusset plate will become sigma Pf into D into T. That means, here sigma Pf is as usual 250 and D is 21.5, but T will become here as 12 because we are considering the gusset, we are considering the plate AD, member AD we are considering. So, this will become 12. So, this some difference you will get from earlier one. So, this is coming 64.5 kilonewton. So, strength of rivet in bearing on 12 mm thickness will be 64.5. Again, strength of angle per pitch length will become sigma 80 into P minus D into T. That means 150 into 60 minus 21.5 into T will become here 10. So, this will become 57.75 kilonewton. So, here we are seeing the least value is becoming 57.75 kilonewton out of these three. One is 58 kilonewton, another is 64, another is 57.75 kilonewton. So, the number of rivet required will be 106 by 57.75. So, this is becoming 1.8, that means 2 number of rivets will be required. So, we have to provide 2 rivets in member AD. So, if we draw the joint, how it will look like? as per the designing it will look like this. Say this is the bottom core with having 2 angle, this is 2 ISA 90 into 90 into 10, this is the center line. This is the vertical line. Now, another member is here. Another member is here. Another member is this one. So, this is 45 degree, this is also 45 degree. So, we are providing some rivets here, it is 4 number of rivets will be required, and the pitch distance we have provided 60 and this is 40. These are 60, 60, 60 and this is 40. So, in this way we have to make it, and here we have to make it. So, in member OC we need 6 number of rivets. So, 1, 2, 3, 4, 5, 6. So, accordingly we have to make the pitch. So, this is edge distance 40 and these are all 60, 60, this is 60, this is 60 and this is again 40, and here the in the bottom core we have 2 rivets. So, this we can provide as 40, sorry 60 and this will be 40 and this will be 40. So, in this way we can draw the joint. Now, this is ISA 65, 10 and this is ISA 70 by 70 by 10. So, this is an example we have shown here how to draw a joint, how to design a joint, truss joint particularly with having different type of forces. So, in next class we will discuss about welding joint, because riveting joint in details has been discussed, how to calculate the strength, how to calculate its efficiency and how to design a rivet joint, that we have discussed. So, in next class we will go for the welding joint. Thank you.